Hello, Matt G for IYT here. Today we're looking at the full license mark examination number 2. We've reached question 8, which reads, what power is dissipated in the resistor in the diagram? And we're shown a part of a circuit or a circuit with a 3.5 kilo ohm resistor, and we're told with this arrow that there is a current of 2 milliamps flowing in this circuit. There's two ways to arrive at the answer for this question. We'll start by looking at the slightly longer way of doing it, but it's a little bit easier to remember. So we are given a current and we're given a resistance, and there is a law that hopefully you'll remember which links those together, and that is Ohm's law, which says the voltage is equal to I, current, times R, resistance. And we're given a current, we're given a resistance, so using these two values we can compute this term V, and that will tell us the voltage across this resistor. If we've got the voltage and we've also got the current, we can then apply Watt's law. Tells us that power is equal to the voltage times the current. So we've got two steps that we need to go through here. We need to multiply I and R to get V, and then we need to multiply V and I to get the power. So let's try plugging some values into our calculator here. We'll start by calculating V, and we can do that by doing 3.5k or 3,500 ohms, and we'll multiply that by 2 milliamps, which is just 2 divided by 1,000, 2 milliamps. And that gives us 7. It gives us the value of 7. So our voltage here is 7 volts. Now, because we've got that voltage, we can now multiply that by the current again, and that should give us the power dissipated. So we'll multiply that by N2 divided by 1,000, which gives us 0.014. Now, in Ohm's law, V is in volts, I is in amps, R is in ohms. With Watt's law, V is in volts, I is in amps, and P is in watts. So we've got 0.014 watts. We multiply that rather by 1,000, and that will give us 14 milliwatts, which looks suspiciously like answer D over here. So there is in fact an even quicker way of answering this, which involves just the one equation, and it relies on us recalling this relationship between Ohm's law, V equals I times R, and Watt's law, which is P equals V times I. And what we did in the previous step was we calculated V and we held on to that number, and then we plugged it in when we needed to use V in Watt's law. But we know that V is always equal to I times R. There's nothing to say we can't just take I and R and plug it straight in algebraically rather than plugging in the number. So what does that look like? Well, we just rearrange this equation slightly and we say P is equal to IR, for that brackets, I, or is equal to I squared R. Okay, so we can say P is equal to I squared R. We've got the I times R times I, so it's I times R, I squared R. Let's plug that into our calculator and see if we get the same result. So we had our I is 2 divided by 1,000, and we can multiply that by itself again with this square button, so square that. And then we multiply it again by our resistance values. We've got I squared, we multiply it now by the 3,500. That gives us our 0.014, which again is in watts, so this comes out as 14 milliwatts. We've arrived at the same answer using a slightly quicker method. Let's skip down to the answer key and see if we've got that right. And yes, we can see because I've highlighted it. Question 8 is answer D, or 14 milliwatts. Thank you very much. I'll catch you for the next one.